Okay, good evening, doctor. So my name is An Sen. My matrix number is TN23002. So today our group will present our group project, which is automated weight-based sorting conveyor system. So, okay, for our course, okay, so the problem is the labor-intensive operation. Second is time-consuming workflow, and the third one is the highly susceptible uh, susceptible to human error. So our solution is the automated approach to the transport, weigh, and physically sort product in a real time without workflow interruption. So next is our core engineering objective. The first one is the transport and weight. So we are using a automated conveyor machine to do the transport for the object and also a load sensor to get the weight of the object. Next is the integrate. We combine the Arduino IDE apps with the Arduino Uno to get the simulation and also the hardware combination. Next is the decide and sort. So um, we already do the coding for the uh, for the Arduino. If the object is less than 10 gram, then the object will be accepted. If the object is more than 10 gram, then the object will be rejected. So the servo motor will be react for the accept and also the reject action. So if the robot is upset, then the servo motor will sweep to the left. If the motor will reject, so the servo you will react for move to the right. Next is the system architecture map. So as we know that the Arduino Mega is our brain for our system. So the power supply is giving the power to our DC motor and also the servo motor because they are using the 12 volt to run the system. The next one is the IR sensor and also the load cells. So they are using 5 volt only, so they are powered by the Arduino Mega. So next, I'll give to my group mate.
Good evening, doctor. My name is Li Wenhui. My mentor number is TP23027. Now I want to present the hardware component. First, we use the Arduino Mega is the center of our conveyor, and then the HX711 is uh, the amplifier module and breadboard writing, and then we have the motor server to station with the physical sorting arm, and the conveyor is assembly driving by the grab of DC motor, and we have some sensor used in our project. First is the IR sensor. IR sensor is detect the object. So when our object at the conveyor the object go through for the IR sensor, the IR sensor will detect object go through. If didn't have the IR sensor, our project drop at the load cell, they will didn't have the result. And second is the load cells. Load self is detect the weight. When the weight is of less than 10, the object is we approve our object, and the object is more than 10 gram, we reject the object. And third, we use the motor server. Motor drive is we make the conveyor runs, and then the shorting arm is detect when our project is accept, they will will go to the left. When the object is reject, the robot arm will go to the right. And this is the sorting life circuit for the sorting machine. First is conveyor will we use the Arduino to given the signal to the motor driver. The motor driver will start the power, and the conveyor will will start, and the IR the object will go through, and the IR sensor will detect the object, and the load cells to detect the weight, and the motor server will give the signal. The Arduino will give the signal to the motor server. The motor server will give the reaction, and then the Arduino will read the web from the load cells. Then the load cell will given the signal to our motor server, and motor server will do the reaction.
Good evening. My name is Lee Chun Hong. Number of ID is TP2T023. So now I will want to discuss about our main logic. So first is the ignore value is less than 2 gram, and the second is the accept region which is from 2 gram until 10 grams, and the last is the reject region which is more than 10 grams. First, we set our servo motor at 90 degree, which is the initial point. The 135 degree is the acceptor section. For the 45 degree is the reject section. At first, the servo will stay at 90 degree when the object pass through the conveyor and reach the load cell. If the mass is from in range of 2 gram until 10 gram, it will shrink to 135 degree, which is accept. If the object is overweight, which is more than 10 grams, so the servo motor will shrink to the 45 degree, which is the reject section. For this is the method to test our main system. So first, we need to test our HS711 is it can trigger the server correctly, and we need also test the IR sensor. Can it count the object how many the object pass through the conveyor? And the most important also we need to test our load cell, and the servo motor is can function based on our coding. So this is our result. The first product is 8 gram, which is less than the weight we set. So it is accepted. So it will shrink to accepted region, which is 135 degree. The second is 5 gram. So it also is less than the threshold weight. So it also go to the accepted region also. The last is 15 gram. So it is larger than 10 grams, so we will reject it, and the server will push it to the 45 degree, which the reject region. That's all.
Good evening, doctor. My name is Lau Ka Chun, matrix ID TN23001. So now I will talk about the achievement of our project. So we have a few stages of achievement. So in stage 1, we have already able to let the cell to detect the force, the gravity apply force, which is our object. So in the stage 2, which is the digital processing, our HX711 able to convert the analog voltage drop into raw integers, and the Arduino Mega filter this through the 10-gram logic threshold, and also the code analyze the data. So while in the stage 3, it convert the signal into a kinetic reality, which is the servo motor translate the digital angle command to the left and to the right using the 45-degree and 135-degree, so into a rotational kinetic energy. So the information become the mechanical action. So the system successfully proved a closed loop cause and effect relationship and automating quality control without a human intervention. So the next is the future improvement in our project. So there's a few modules that we can apply on our project to have further improvement. The first one is the mechanical flow. So in the mechanical flow, it can be engineering perfectly smooth mechanical transition from the moving conveyor belts onto a stationary load cell platform to reduce the frictional data noise. The second one is integrating an LCD display module to provide factory floor workers with real-time visual, week readout, and product counts. The third one is adding a piezoelectric buzzer as a third output system to provide an immediate auditory alarm when there's a defective item is rejected. So as conclusions, our project has delivered automated quality assurance by seamlessly integrating the sensor inputs with intelligent kinetic outputs. This system transforms raw physical data into instantaneous quality control, proving a scalable and better solution for the modern manufacturing floor. So now I will show the video of our demonstration for our project.
Hi Nisa. Okay, good evening. So today we will present our group project, which is the automated sorting system. So this is the conveyor. The sensor that we use is IR sensor, brake sensor, and the motor we use is the gear motor, DC gear motor, and also the servo motor. So this is the Arduino that we use as a brain for our whole system. Then we use the Arduino to do the coding. And then here is my in my hand is the object that we will detect our sorting system, which is if the object is less than 10, then we will accept. And when we accept the object, the servo motor will hit to the right side. So if the object is over 10 gram, then the object will reject the DC motor will the servo motor will reject the object, which is you go to the left side. So we'll start to do the simulation. So as you can see, when the weight is less than 10, then it will reject to the left. So following by the object. So our IR sensor is as a sensor that counting how much the object will go through with the system. So this is the object that over 10 gram. So as we can see that the object will be rejected, so we will hit to the left side. So this is our whole program for our group project.